Right now, the universe itself is still tearing apart at two different speeds at the same time, and NASA, Hubble, and every cosmologist on Earth has no way to stop it. They call it the Hubble Tension, and what scientists found buried inside this number is the part they are afraid to say out loud. The universe is expanding. That much they have known since 1929. Edwin Hubble looked through a telescope and saw galaxies racing away from us in every direction. The farther they were, the faster they fled. A simple, beautiful equation. One number, the Hubble Constant, describes how fast that expansion is happening. If cosmology has a foundation, that number is it. So scientists measured it. They measured it from the early universe, the Big Bang's leftover glow, the cosmic microwave background. And they measured it from the nearby universe, Cepheid stars, supernovae, the visible cosmos we can map. Both measurements should agree. They are measuring the same universe with different tools. Two different rulers should give you the same answer. They don't. They give you numbers that are impossibly, stubbornly, catastrophically different. And that gap has a name, the Hubble Tension. The early universe says the cosmos is expanding at roughly 67 kilometers per second per megaparsec. The local universe says 73. That sounds like a small difference. It is not. It is a 9% discrepancy. In physics, a 9% gap between two measurements of the same fundamental constant is not a rounding error. It is a crisis. The Planck satellite mapped the early universe with instruments so precise they could detect temperature differences a millionth of a degree apart. The Hubble Space Telescope spent 30 years measuring stellar distances across our cosmic neighborhood. Both instruments are the best humanity has ever built. Both teams checked their work, and they still disagree. By 2019, the statistical confidence of this tension hit 4.4 sigma. In science, 5 sigma is what you call a confirmed discovery. They were almost there. Scientists ran every possible check. They found no mistake, but that's not even the part that worries them. The first instinct was calibration error. Maybe the instruments were wrong. Maybe the math had a flaw buried somewhere deep. They checked. They rechecked. They used entirely different methods. Gravitational lensing, surface brightness fluctuations, megamasers orbiting distant black holes. Every independent measurement of the local universe kept landing near 73. Every measurement rooted in the early universe kept landing near 67. Then the James Webb Space Telescope entered the picture. Webb was supposed to settle this. It is the most powerful observatory humanity has ever launched. It can see galaxies forming in the first few 100 million years after the Big Bang. Webb looked. Webb confirmed the tension is real. The number has now crossed 5 sigma. That means this is no longer a measurement problem. This is a physics problem. Here is what they are afraid to say out loud. The standard model of cosmology, lambda CDM, the equation that describes everything from the Big Bang to the great web of galaxies stretching across the visible universe, may be wrong, not incomplete. Wrong, because the Hubble tension is not just a gap between two numbers. It is a signal that the early universe and the late universe are behaving by different rules. The same cosmos, different physics. That should be impossible. Physical constants are constant. That is the entire premise of science, unless they are not. There is a growing faction of physicists who now believe dark energy, the invisible force accelerating cosmic expansion, is not constant. It is evolving, growing stronger over time. Some models call it phantom dark energy. Under this scenario, the universe is not just expanding. It is accelerating its acceleration. The expansion is speeding up faster than any equation predicted. And there is something else. A handful of physicists are now seriously revisiting whether Einstein's theory of gravity itself needs to be rewritten. General relativity has survived every test for over a century. But if the Hubble tension holds, if every new instrument confirms it, then our deepest understanding of how space and time actually work has a crack running straight through the middle of it. Think about what that means for everything built on top of it. Every model of the universe's future, how long it survives, how it ends, whether it collapses or tears apart, depends on knowing the true expansion rate. And right now we have two true expansion rates that cannot both be correct. If dark energy is growing, the universe does not slowly freeze. It tears. Every galaxy, every star, every atom eventually ripped apart by an expansion that never stops accelerating. Scientists call that scenario the Big Rip. They used to treat it as a fringe possibility. The Hubble tension is making it look less fringe every single year. We are not talking about a measurement dispute. We are talking about the end of everything calculated wrong, because the math we trusted most is already broken. And here is the question nobody can answer yet. If the universe is operating by different rules at different moments in its own history, what else in our cosmology is wrong? What else have we been measuring with a broken ruler this entire time? Drop your answer in the comments, because the physicists working on this right now don't have one yet.